Thank you. Thank you very much. And thank you for having me here to speak specifically about drainage and what we're doing in Network Rail, what we have done and what more there is to do. So as mentioned, I'm Mona. I'm the professional, formerly known as the professional head, one of our many job title changes, formerly known as the professional head for drainage and line side. I want to talk a little bit about our approaches, why we did those approaches, what we hope to achieve, and what still is left to do. And the first thing, I guess, for me that was really clear is regardless of incidents and changes and recommendations, if you want change, there must be a desire and discontent to change, because otherwise you're shoving things down people's throat and it ain't going to work. We all have to say, actually, we do want to change, and therefore we will change. And so some of the things I'm going to talk about is how we've done that and what's there going forward. You've recognized the photograph from a very recent presentation that you've just seen. That is Carmont. Carmont was a massive catalyst for us to actually accelerate some of the things that we were already working on. We had, as Juliet had mentioned, there were things in the pipeline. There were things that we were already talking about doing. And post Carmont, with the recommendations both from RAVE, internal, as well as the task force, that accelerated the delivery of some of the things that I'm going to show you and talk about in this very limited 20 minutes. And happy to talk more with some of you about what else we're doing outside of this. So we've got some massive challenges, right? Climate change is here. It's now. It's not a project thing. It is actually here. We have more extreme and adverse weather events that are unpredictable weather patterns. Where's the water going to be? How much is going to be? Where is it going to go to? We have heat as well as too much rain. We're going to see intense rainfall covering shorter periods of time, and we're going to see longer, hotter summers. So you almost have too much water or not enough water. We have legacy assets. There's over currently about 500,000 drainage assets recorded in ELIPS, our master register. And those are legacy assets that were designed. These drainage systems were designed on older standards that didn't consider climate change and the resilience that was needed. So these assets that are currently in the ground are tested in these extreme and adverse weather events. Sometimes we don't pass those tests. And the frequency and intensity of that testing of those assets is happening more and more. So we're got a massive challenge here around legacy, moving forward and changing the approach that we are using for the design, construction, the evaluation of drainage in this place. So focusing specifically around drainage and rainfall, the consequences of extreme and adverse weather events are failures not just for the drainage system itself, over-exceeding, flooding, etc., but it has a consequence on other asset groups. So washouts, landslips, wet beds, track geometry faults, track electromechanical faults, water and electricity don't get on. You see a lot of negative impact when drainage doesn't perform as it should on the railway as a system as a whole. And so following off just what Julian said, it is one system, the drainage system sitting in the railway system. We should not look at things in isolation here. So where do we start? Where do we do? Yes, we've got recommendations, but what do we change first? And where do we begin our journey? For me, the first thing was to say, well, let's look back. And I also don't really cover a lot of Carmont because of the sensitivity of where we are with the investigations and the inquiries going on at the moment. But we looked from the time of Carmont, we looked back. We looked about 20 years. And what we did was we said, well, was this an isolated incident? Was this unique in this one place? Or actually, was there other things that had gone on? So we went to the RAID website. We went to the ORR website. We went to the big national NIC papers and big task papers that had come out. And we looked backwards and said, where, if we searched for the words drainage, rainfall, flooding, exceedance event, where do we see things popping up? And you see there's a lot. Almost every 2 years there was an incident. So that's quite a lot. There's quite a rich history, a lot of reading and context. So why aren't we quite learning from these past incidents? What is going on? I think there's two things that happen. One, if we look at an incident in its own self, you only stick to the events that are in that one incident, and you don't start to look at the wider picture, the patterns of what's happening in other places. So you could lose that learning if we just focus on one thing. So look wider. Where else is it happening? What's the bigger picture telling us? The other thing is, if we only look at it from a asset-specific silo perspective, it's a drainage failure, it's an earthwork failure, it's a track washout, we lose the causal relationship that is there in some of these. We don't live in a seismic zone, so Earth doesn't usually move on its own. It's something that's creating that movement. I say to you, it's water. Where is it coming from? Rain, saturation, oversaturation, etc. Ballast doesn't just wash out one day because it just doesn't feel like being where it wants to be. It's water and the energy surges that are in that potential kinetic energy that's pushing that stuff away. We need to recognize that and appreciate that, and we need to manage it. We need to manage it today and move forward. So looking at these, and these are not all, by the way, sir, these are the big ones. These are the RAVE reports, the ORR reports. These are not all the incidents. We have internal reports as well that we looked at. There's a system that appeared a few times. Looking at not having an effective strategy, competency, weather exceedance, exceeding our expectation. We were caught unawares. We weren't aware that this was going to happen. Those started to have causal, so recommendations leading to other recommendations leading to other. The big circle in the center, not performing or exceeded capacity, is our bow tie threat. That is the key trigger there. That then causes your landslips. That then caused the track circuit failures, accentuated track circuit failures, which then led to derailments, and then you had the incidents. So we started to piece together, hang on, there's a lot going on here, and if we could group these and go from a multi-pronged approach to the changes that we need to do to address the recommendations, to embed the change that we wanted to make within Network Rail for drainage, we could do it. Drainage is young, it's immature. Where Earthworks started their journey in 1995, I would say that drainage started their journey maybe in 2014, 15. The role of head of drainage was only created in September 2015. So it's not very old as far as a focus of an asset group. It was always considered a child asset. I hate that term. So it was a Cinderella asset, child asset. Well, I'll tell you now, this is one sexy bitch up here, right? Not me, drainage, right? She's causing all sorts of problems, not me, drainage, out there on the railway. And we need, she's high maintenance as well, let me tell you. We need to focus on her because she's causing some problems. I said I wasn't going to swear, I just swore, sorry. Where's Peter? He doesn't have to wind me up. Yeah, you don't have to wind me up. There you go. You get £1. So multi-pronged approach. Okay, how are we going to address this? Not just Carmont recommendations, but past. Let's learn together. So let's make a change. Let's not be where we want to be. Let's not repeat the past. Let's move forward. So it sounds a bit boring, but strategies and policies. Well, the purpose of a strategy is your long-term vision. So we want to change, but what do you want to change into? I don't know. I just know I'm not happy with what's happening now. Okay, so the first question you need to know is, well, what do you want to be and where do you want to go? So that's what the drainage technical strategy was. As a collective group, we got together. What are we not happy with? And just get it all on a piece of paper or Miro board at the time. Just get it all out. It's very therapeutic. This isn't right. That's not right. This isn't working. That great. Well, let's flip that now. What do you want it to be? And what we wanted it to be aligned to 32 ambitious statements. We wanted to be a good neighbor. We wanted a complete, accurate drainage system inventory. We want a holistic view. We want a sustainable future. We want effective, efficient drainage interventions. We want the right number of competent resources. Who doesn't? All of these things I just mentioned, I won't rattle all 32 off to you, but they were all aligned to what we had agreed. So that's what the strategy defines, where we're going, our 10, 20, 30-year vision. And each ambition has details around what examples does it look like, what's the objectives we're trying to achieve. And because it's a national document, there's no way we're going to do all that tomorrow. But what it allows is each of the regions to select those pieces that are close to their risk appetite, that they're passionate about, and say, I'm going to focus on maybe these 2 or 3 things and just really work on that. And I'm going to mature my approach to drainage asset management linked to that. And we can measure that. That's brilliant. So we can start measuring our maturity as we go forward. So that's strategy. Drainage asset policy is, in Network Rail terms, policy is not what asset management defines as policy. Our policies are guidance to strategic business planning. How are we going to create work banks for CapEx or OpEx? And how are we going to know how much money and cost of volume we need? And what are the benefits we're going to achieve? And how do those work items align to the corporate risks that the business have: safety, performance, environment, carbon? And so the drainage asset policy basically introduces 3 levels. It says you can be reactive, you can be preventative, or you can be proactive. But it's in a very adaptive approach. So you can have it against safety, performance, finance, environment, carbon, asset information. And we've created a Power BI tool that allows our decision makers to have a bit of play and saying, if I'm a reactive approach, how much money do I need? If I'm going to have a proactive approach, how much money am I going to need? How much volume is this going to take? And not only does it do that, the tool does do that. So for my £100, it says for your £100, you will get a benefit of a certain percentage of reduction in your risks. That's really powerful. It gives a strong business case for us. So luckily we walk into CP7 with a little bit more funding than CP6, but of course, as Julian also mentioned, that's not locked down. So until it's locked down, it is what it is. Okay. And then our standards are lovely, lovely standards that sit to the side, which should have our minimum requirements. This is what we need to do as minimum requirements. And we're going to be updating those as well. So challenges we got for CP7, what are we going to do? We need to mature. We need to carry on chipping away at getting better and better at our maturity. We need to start applying those adaptive approaches to our business planning to say, if I get this amount of funding and I deliver this bit of work, I'm going to achieve these benefits and get those benefits, start measuring those afterwards. So that's happening at a very, very high level. More detailed level, we're updating the standards to strengthen our terminology around what is vulnerable assets, what is catastrophic failures, what are we talking about when we talk about different intervention levels. And we're also updating our standard detailed drawings to provide better designs, more blue-green solutions, more solutions that think about how water and drainage's components can possibly fail. So what we're talking about here is, for example, let's not put French drains on steep slopes with infill material. We're just creating water slides that are pointed right at the track. Let's do something differently in that space. And what is that difference? That's the sort of things that we're doing right now. So that's still coming in the next sort of year or so. In doing just the drainage work, yes, water is managed by drainage, but it is not the only asset group that manages water. Water influences track, signaling, electrification, earthworks, every asset group and every function on the railway: design, inspect, maintain, construct, evaluate, all are impacted by water. And so what we realized is that we couldn't, in just writing a drainage technical strategy, we weren't addressing the big railway and water interfaces. We could only do it as an asset. And so Network Rail, we pitched to the chief engineer that we needed a national level water management strategy. And I'm going to play a little video for you on that now.
Introducing Network Rail's water management strategy. This strategy is going to change our approach to water management. But before I tell you more, this is why we need it. Climate change is happening now, making the consequences of extreme and adverse weather a reality for all of us. Flooding and droughts already cost Network Rail millions of pounds a year and are only likely to get worse. From landslips to electrical failures, weather-related incidents affect the safety and performance of the railway, resulting in penalties, delays, poor environmental impacts and a disrupted service for our passengers. But we can improve. Network Rail is committed to running a reliable railway network. To do this in today's world, we need to prioritise water management. This means dealing with the water that affects all of our railway assets. We need to grasp the wider challenges of water scarcity, polluted water, and the potential benefits of excess water, in collaboration with our neighbours. We've developed the water management strategy consisting of 5 principles. These are: take a holistic view, be resilient, use less and recycle, keep it clean, and unlock wider benefits. We are the first in the transport industry to develop a water management strategy. It's an opportunity for us to demonstrate our proactive leading approach. As the 4th largest landowner in the UK, we can make a profound impact. Water affects all of us on the railway. Every asset group and all life cycle activities, including inspection, maintenance, design, construction and asset management, have a part to play. We all have a responsibility and we need to start today. So, how do you make a difference? Start by engaging with the water management strategy. Go to the My Connect page for more information.
Sorry, I should have mentioned My Connect page is an internal Network Rail link, so the QR code will only work if you're a Network Rail. But I'm more than happy to share the interactive PDF document so you could have a bit of read through and see what's there. So water and its role is changing in the political landscape and the legislative landscape. SUDS, Sustainable Drainage Systems, now is a requirement. So Schedule 3 of the Flood and Water Act require any developers, councils, and actually even Network Rail to put in SUDS, Sustainable Drainage Systems, which means that we hold more water than we actually just sort of let go through. This is different. This is a new way of doing design and construction, so we need to start to consider that. That's all asset groups, so stations, etc. as well. The other thing that is changing is this concept of catchment communities. We alone, water doesn't care about boundaries and where the fences are. Water surface runoff is going to come through our land and go into our neighbor's land. So we need to start looking at some of our solutions in a more catchment-wide scope and work with highways, adjacent landowners, councils, to build schemes and solutions to where we've got our water surface runoff problems with them, because they probably have them as well. And that's a different approach for us in Network Rail when it comes to partnership funding and collaboration in that perspective. But that is what we have to do. It's not easy. Oh, we've never done it before. Who cares? We have to do that. We got to move forward. And the other thing is an awakening of the understanding of water and hydrology and hydraulics, where Earthworks engineers were maybe introduced into the business in 1995. We don't have a lot of hydrologists or hydrological engineers. We've got engineers who maybe learned from others about what drainage is. We can't do like-for-like renewals. We need to do things a bit differently here. So it's about awakening there in this space. So speaking about catchments, one of the data sets that we have recently created and launched is live in Jira and Viewer, which is our mapping system in Network Rail, is catchments. These are specific catchments where the surface runoff from these catchments where the water goes towards the railway. So these are not your big river catchments with EA. These are specifically those where a drop of water will flow and come towards us. So we identified the delineations of the catchments. We have looked at various return periods and said how much volume of water per second will meet at a funnel point on each of these catchments and come towards the railway. And then what is that water threat index? So the more water coming, the higher the index, the probability of it. Steeper slopes, bigger catchments, lots of water coming right at us. We've never done this before. I sort of, now that we've done it, I was like, goodness me, why didn't we do it? Because wouldn't you like to know before you put your electrical substation somewhere that it's in a high water threat index? There's lots of flooding there. Or wouldn't you like to know if you've got speed restrictions that you need? Actually, the water is not a problem there. It will flow away, so we're okay. This is something that's new, and it's something that we're going to be pushing more and more in CP7 as we move forward. The use of this information in risk assessments, the use of this information in any of our designs, the volume of water coming at you. Why don't we design for that? Oh my goodness. And it's not just for drainage. This is for any asset group. So if you're in track and you get a lot of track geometry, repeat track geometry problems or wet beds, have a look at the catchment in that area. Do you have water flowing through the track? That's the problem. If you're building an electromechanical works, have a look. Are we in a high threat zone here? It's for all asset groups to look at, scour, etc. as well, and as well as our Earthworks colleagues. That's CP7 to push this information out more, get others to use it, and of course, as usual, we update the data sets as we get more fresh data in and new and better data. I'm going to try to speed it up, I promise. Technologies, right. So I talked about some of the documents we've written. We're doing a lot of technology development. So catchment was one. That is a lot of technology. There's a lot of tools coming out. Basically, what you've got is a decision support tool, a risk model, a workbank management tool, an asset risk evaluation tool. We've got an FTE calculator that basically says, based on the minimum requirements of our standards, how many people do we actually need to do the minimum requirements of a standard? I don't know of any other asset group that's ever done that. It came out of a recommendation from Carmon. You need to have the right number of people to do inspection and maintenance of your assets. Well, how many people is that? So we built a calculator off of that. The adaptive planning tool I slightly mentioned as well, and I'll talk a little bit about competence in a second. But tools like streams and asset risk evaluation, these are really leading the way. We're actually even challenging Microsoft to fix some of the things that don't work for us. So Microsoft at a global level are changing some things because of what we're trying to do. And that surprises me sometimes. Little old drainage tool trying to come through going, hang on, big old Microsoft, you didn't figure this out? Okay, we'll challenge you to do it. So there's a lot of technologies up there, a lot of tools. The whole idea is that they will all come together under Streams. Streams is the one-stop shop for all of our data and information so that the decision maker for drainage can go into that, and it could be maintenance, it could be designer, it could be the asset manager who's like, right, get me into one place, tell me what I need to know about my condition, my assets, the location, about history of flooding, about any other things I want to know, washouts, what's happening with track geometry, bring it all in one place, all mapped out, geospatial, happy days. I could create polygon shapes and then create workbanks out of it. Good times. Streams, all in one stop. Stream stands for Strategic Engineering and Asset Management System. Hardest part of technology is finding a good name for your tech. Honestly, it is. Of everything that we do, the most important thing that we're doing is our people, and we're looking at the training and development of our people, and that is through. There's a competence standard now that defines the competencies and the different proficiencies linked to those competency statements. We have created 2 guidance notes, one on route to competence, because competency in the competence framework within is very complicated. It's not just do training and do one thing. It's training, it's experience, it's academic, it's professional affiliations, it's further learning, it's mentoring, it's saying, I need to know something to do the job I want to do today, I am doing today, but tomorrow I want to do a different job. So what do I need to know to do that future job? So how do I create basically a career pathway? How can I develop and go forward? Where do I go next? If I'm in drainage and if I do drainage and line side. So if you're in drainage and line side, AKA off track, where do you go next? What branches out, and where can I go for more? So the competence framework is quite complicated in its own right, and the handbook explains some of that. So what do we do now? We're developing e-learning material. We're developing some practical face-to-face training material now, which will be launched. E-learning material will be launched later on this year. which will give people an awareness proficiency. And then we'll have practical face-to-face, which will give folks an understanding proficiency. Then they go do the job that will give them the applying proficiency. And then from there, you get leading and experts. But we're focusing on understanding and awareness first, and then folks to use it on the ground, give us the feedback. So that's coming now, and that will happen through CP7. We are also looking at academic qualifications. Where can we send folks to get NVQ qualifications, and how can we support them in that space? Internal network role training won't give you academic qualifications, but if you're so desired to have them, where can you go? There's experiential experiences of using professional affiliations like PWI to say, right, how can I be an IEng? How can I get chartered? How do I become a fellow? What are the paths that I've got in that space? And I say PWI because I'm here, but there are other organizations as well. This is where your heart belongs, hopefully belongs here. So you've got professional affiliations as well. And that's all part of that learning and development. You invest in people and people do respond. I genuinely believe that. Forget all the tech, forget writing good standards. If you invest in people and they've got the right competencies and there's the right number of them, you could do so much. You could do so much. And so I'm going to close with four kind of points to just sort of summarize the challenges for CP7, but what we've done as well. So number one, it's here. Climate change is here. It's now. You can't ignore it. The risks are today. So you either step up and meet the challenge, which means we've got to change some of the way that we're doing things, or we face the consequences. Facing the consequences is going to cost you a whole lot more. It's going to hurt a lot more. So let's meet the challenge and let's change where we need to. Change and improvement needs to be multi-pronged. So just doing one thing sometimes isn't enough. And actually, I think from historically looking back, just changing the standard, just changing the drawing, just changing one thing doesn't quite embed the change that we need. So multi-pronged approach, strategy, policy, standards, drawings, tech, training, boom, it's all coming a lot. But that multi-pronged approach is what's going to create the change that we need, embedded change. Plans need to be adaptive. They need to be system-based. There's the drainage system. There's no track drainage and earthworks drainage. There's the drainage system that sits in the railway system that sits on in the UK, that sits on planet Earth, part of the water cycle. There is systems upon systems. So you need to be adaptive because your funding's changed, adaptive because we've learned something new, adaptive because a new data set's appeared, catchment, and I can now use that. So respond to known and emerging risks and be able to be adaptive in that approach is key. And then all of the modeling, the tools, the technology, they're all there to support the decision-making process. And the decision-making process should be done by the right resources, but let me rephrase, the right competent resources, because that is really where the true change and reality of change will come.